Happy Friday, Ross.
Happy Friday.
Happy Friday. We made it. Another week of this.
You like my smile?
I love your smile.
So nice to not be wearing my mask right now.
Yeah, what's up with that?
Well, I had to wash it.
Oh.
It's been a couple of years.
Ew. Couple months anyway.
So
I
it's
just,
fine.
this hasn't been a couple years. I just made it.
Thank
Okay,
you.
you're welcome. Now it just looks like a neckerchief.
And my name is spelled R-O-S-S. Email me.
Okay, I see where this is going. But I don't think you have your own email address, so it has to come to me,
Yes.
and I will make sure
You share. Thank you.
I will share.
Happy
Yes.
Friday.
Happy Friday. Here we go again. Okay, we did a lab yesterday, and we
Yes.
have sugar all over the place. That gross sugar, but a lot of it dissolved in the hot water. So our conclusion, well, for your observations, you have your data table. Yeah.
I have an observation too.
Yes.
I chased the ants out after all the sugar.
Oh, the ants. Well, they're just kind of,
Hope you didn't have ants at your house.
they're afraid of you, aren't they?
Easy to chase.
Easy to chase, little ants. Okay. Yeah, thank you for that. I'm not a big ant fan. Although I do like the movie Ant-Man, but I'm not an ant fan. Okay, so your observations included what you saw happen and your data table to go with it. And I added another chart up here. We'll talk about this in a minute. This will go in your science notebook with your notes, probably with your 10.2 notes. Because there's a chart on page 11, but that talked about pressure and solubility. And I was thinking it was temperature and solubility, but it's not, it's pressure. So I put the temperature and solubility chart up here, so you can copy that down too in your notes. Okay, question number 1, which temperature dissolved more sugar?
Hot.
Hot, the hot water. Which flask reached its saturation point faster?
I got dizzy.
You were dizzy. The cold one reached the saturation point faster because the saturation point, because saturation is the definition of saturation that was in your notes. Saturated is on page 9. A saturated solution is a solution that has the greatest amount of solute that can dissolve at a given temperature. So once it stops dissolving, it's saturated.
Yes.
It's done. Okay, so the cold water reached its saturation point faster than the hot water did. We actually don't even know what the hot water saturation point was because we stopped because it was
got dizzy.
because you got dizzy and it was taking too long.
It was saturated.
It was set. No, it wasn't saturated. The hot water wasn't. The cold water was, but the hot water wasn't. We could have dissolved more in there, but you were dizzy and I was tired of doing it. Okay, number 3. Compare the solubility of solids and gases in warmer solvents. How are they different? And here we are to the chart. So it doesn't matter what the solvent is. If the solute, the stuff you're adding, is a solid, when the temperature goes up, the solubility goes up, just like we did. The warmer the water was, the more it dissolved, so the solubility went up. When the temperature goes down, the solubility goes down. So the cold water couldn't hold as much, it didn't dissolve as much. Now gases are just the opposite, exactly the opposite of solids. If the solute is a gas, if you're pumping gas into something, the warmer the solute, the higher the temperature, the warmer the solute is, the lower the solubility of the gas is. The gas won't dissolve in the solute when it's warmer, just the opposite of a solid. And it's the opposite with the colder temperature too. When the temperature goes down, when it's colder, the solubility goes up. That means that you can dissolve more gas into something when it's colder. So then we get to the bonus question. Why do you want to keep your sodas cold? what's in a soda.
It tastes better, and the carbonation makes me go, whoa!
Yeah, so the carbonation, what is the carbonation? What do they put in soda to make it carbonated? Okay, they put the carbon gas, okay, they get the carbon dioxide gas in there. So if the gas that contains the carbon in it gets into a colder temperature, it's going to stay dissolved in there longer. The warmer it gets, the flatter your soda is going to get because it doesn't stay soluble in warmer solvent. Okay, does that make sense? So you want to keep your soda cold, but only if you like fizzy soda. If you don't like the fizz, then leave it out and it'll get warm and it will go flat. But that's kind of the point of soda, is to keep it fizzy. That's why they put the fizz in it in the first place, because otherwise you're just drinking like sugar syrup, like sugar water, like we made yesterday. Yeah, okay. So that's your lab. Take a picture of it, send it to me, and you have a reinforcing key concepts 10.2 reinforcing key concepts worksheet to do. It's on my website under the worksheet heading, and I think everything you need is there. You will need this to do this, so be sure you copy this down, and also the chart that's on page 11 in your chapter 10 review packet. Okay, I think we're good. That's a wrap for the week. Another week of May. You know, we thought this year was going by fast. I thought this year was going by fast. And then they just yanked it away from us.
Yeah.
Yeah. And it's really sad. So, anyway.
I miss you all so much. She misses you lots.
Yeah, I do. Okay.
Be good humans.
Be good humans. I love you. Bye.